Alright, welcome to Geometry 9-3. We're learning about permutations and combinations. And the first thing we're learning here is called the fundamental counting principle. And let's go ahead and work on a definition for that. Mine's a little bit different in the book, but all I have here is for two different events. And those events we'll call M and N. Event M followed by N can occur M times N different ways. Let's look at this one more time. Okay, so if we have two different events, M and N, two separate events, to figure out event M followed by N, they could occur M times N different ways. So let me just make an example here. Let me use different color. Let's say that event 1 is flipping a coin, heads or tails, right? And event 2 is using a spinner, and there's 3 different ways that the spinner could fall, right? So to pick an event from here, from event M, so let's say heads, followed by any event from here, let's say it lands in this quadrant, or it wouldn't be a quadrant, sorry, section, let's go section 1, 2, and 3. However many different ways that could do of having an event happen here, and then happen here, would be M times N. So in this case, there's a total of 2 events on this side and 3 here, so there's a total of 6 different events that can happen in total. And that's called the fundamental counting principle. Let's look at a more detailed example. So, a deli offers the following lunch combos. So you can see we have a list of all the sandwiches here, a list of all the sides here, and a list of all the drinks here. So the fundamental counting principle says that you're going to multiply the number of events in each of these to get a total number. The question here is how many different lunch specials are possible. So how many different combinations of ham, chips, and water, or club salad, and juice can I get? And so sandwiches, we have a total of 1, 2, 3, 4, 5. We have 6 sandwiches times 1, 2, 3, 4 sides times 1, 2, 3, 4, 5 times 5 different drinks. If you multiply all that together, that means that there's 120 different combinations you can get at the deli. That's it. Let's move on. So a permutation, let's define this together. A permutation is an arrangement of items in which the order matters. Excuse me. Alright, so an arrangement of items in which the order matters. Meaning, another way to think about order mattering is that the elements here, or your items, they can't repeat. So for example, I said, hey, how many different ways can these 5 people line up in a row, right? Well, for the first one, use different color. For the first person, right, the first slot here, there's 5 people to choose from, right? But let's say Kate goes into the first slot. Well, now how many people are there left to choose from for the 4th slot? There's only 4. Let's say Chris went into the 2nd slot. Now how many people are there to choose from? Only 3. Let's say it was John. And then Jordan gets selected. And now there's only 2 people left, and then lastly there's only Alfred, there's only 1, right? So the number of different ways is going to be 5 times 4 times 3 times 2 times 1. Or in this case, 120 different ways that they could line up. Let's move on. Okay, so how many ways can 8 songs be shuffled? This is kind of continuing here, right? Well, the first song comes on, that's 8. And then the second song, there's only 7 left to choose from, and then 6 left to choose from. Let's do it. And then there's only 5 songs to choose from, and then 4, and then 3, and then 2, and then 1. Now, obviously, this takes a long time to write out, right? Again, let me just recap here. How many ways can 8 songs be shuffled? Well, once the first song comes on, now there's only 7 songs left to choose from. And then once the 7th song plays, or another song, I should say, now there's only 6 songs to choose from. That's why this is decreasing. This is called factorials. And we could write this whole 8 times 7 times 6 times 4 times 3 times 2 times 1. This can get written as 8, and this, you read this exclamation mark here as factorial. And what this factorial means is this whole thing right here. It means 8 times 7 times 6 times 5 all the way down. So if I had 5 factorial, that means 5 times every number, 1 less than itself until we get to 0. So 5 times 4 times 3 times 2 times 1. Or I guess until we get to 1 is more accurate there. So how many songs can 8 ways be shuffled? If you look and you have... you might have on your calculator 8 factorial, but in case you don't, we're just going to do 8 times 7 times 6 times 4 times 3 times 2 times 1, and that gives us 40,320 different ways that 8 songs can be shuffled. Crazy, huh? Let's continue. So permutations really deal with selecting a certain amount of items out of a larger amount when order matters. So for example, let's say we had that 8-song scenario again, but in this 8 songs to shuffle, in the card that I have, I only can have time for 3 songs. So just with looking at those 3, how many can be played? Well, let's look at when the first song comes on, and I'll explain this in a second. When the first song comes on, I have 8 songs to choose from, right? When the second song comes on, I only have 7 songs to choose from. And when the third song comes on, I'll only have 6 left to choose from. And then that's it, because I only could play 3 songs. So 8 times 7 times 6 is going to give me 336 songs total to choose from. Now what does this mean? What does all this mean, right? Well, first of all, this P is for permutations. And this is a permutation because the order matters, right? The songs, once that one song is picked, it's used. So I can't use that song again here because the order it came in was the first order. That's why there's 1 less. But n in this equation here, n is the total number of songs I have. So n in this case would be the 8 songs. R is the number of songs that this problem is concerning, meaning I only could play 3. So n permutation R would mean the number of songs, n, would be 8 divided by the number of songs total minus what I'm looking for, factorial. And let's just see what this means here. So this would mean 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 8 minus 3, which is 5 factorial, right? This bottom here would equal 5 factorial. And that would be 5 times 4 times 3 times 2 times 1. And you can see here that we're able to cancel out 5s, 4s, 3s, 2s, and 1s. And all that's left is this, which is how we get to here. But this is a good thing to understand in case we're dealing with bigger numbers. So the total number of permutations for the set order would be the number over the total number minus what we're looking for. Combinations. Well, first let's define combinations. Combination is a selection of items which order is not important. Meaning things can repeat and order doesn't matter. So let's look at this. So this would, for our formula here, it's the total number divided by, and now we have an R factorial multiplied times, again, the total minus R factorial. So let's look at an example. Let's look at example problem number 3. Let me see if I made a... I think I did. Okay, cool, yeah. So for this problem, it says you have 12 books that you want to read over summer, right? But over summer, you only have time to read 4. So how many different combinations of books are possible? So you can see combination, right? I mean, different combinations. It doesn't matter what order you read them in. as long as you read 4 books out of the 12 that you have. So to do that, let me change colors to blue here. We have a total of 12 books. Over, we're looking for 4, and then 12 minus 4. So we set up our formula, and then let's just play this out a little bit. So simplified, we have 4 factorial over 12 minus 4 is 8 factorial. So just to show you this multiplied out here, 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over, and we have our, I'm going to start with this 8 factorial here just to line it up. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And this is times 4 factorial. It's going to be 4 times 3 times 2 times 1. Okay, so that's it. So let's see what we can cancel out. We can cancel out 8, 7, 6, 5, 4, 3, 2, 1. And we're left with this. Well, multiply the top, and you get 880. And on the bottom, you get 24. And if you divide that, you get a total of 495 different ways to read 4 books out of your 12. There's 495 different combinations. Let's look at one last question. Problem number 6. So, we have pool balls numbered 1 through 15. What's the probability of choosing a 5, a 7, and a 9? Well, first we're just looking at how many different combinations are there. If I picked 3 balls, how many just different combinations are there? Because again, let's just start with probability is what event am I looking for, right? So the event I'm looking for is choosing a 5, a 7, and a 9. Over the total number, so the total number would just be how many events are there of just picking 3 different balls, right? So, and this is what we first thing to deal with, is just how many different ways are there, how many different combinations of just 3 balls are there from 1 to 15. So this is a combination. So it's 15 combinations, or 15 combination 3, right? So this is going to be 15 factorial over 3 factorial times 15 minus 3 factorial. This equals 15 factorial over 3 factorial times 12 factorial, right? And if we do this, we get that there's a total, if we did all that math, there's a total of 455 different combinations of 3. But we're not done yet. This just tells us, again, how many different types of combinations of 3 are there. There's 455. Well, now we got to figure out how many different ways can I choose a 5, a 7, and a 9. And let's just look at that here. I have 5, 7, and 9 to choose from. Well, the first time I could choose either a 5, a 7, or a 9. There's 3 different ways. The second ball I choose could either be 2, less than that, and then 1. So the fundamental counting principle says that there's 6 different ways to choose those 3 balls. So total then, 6 divided by 455 total ways to choose 3 balls gives me a 0.013. Or if I want that as a percent, it's a 1.3 chance of choosing a 5, 7, 9, or order doesn't matter. Okay, good luck in this section, and I'll talk to you soon. Bye.